A very good morning to one and all. I'm Praveen Kumar. So today I'm going to show you a practical demonstration of my resilient event-driven API, which was built using Django and PostgreSQL. So coming to the problem what we are facing. In building modern distributed systems, we often face the problem called dual write problem. So what happened is, suppose you are having something, a restaurant and you have two services. One is when an order was created, it need to be saved in your database, and also it need to call another service, for example say billing service. So at a time we need to process both the events, so it is not possible to act simultaneously. So there might be some problems, for example say if database saves and due to the network drop fails, the event was not sent to the billing service, so it's an problem. Or if we send the request first to the service billing service, and when the database crashes, we have sent the event that never happened in our database. So this is the problem we are facing in building modern distributed systems. So I solved this problem by building an transactional outbox pattern in Django. Okay, let's see the practical demonstration as well as some concepts used in this project. Yeah. So the problem, how to automatically update the database and send message to the message broker. So here we are using message broker to send our message to the another service, say billing service. So the database and or the message broker might not support two PC. What do we mean 2PC? It is nothing but two-phase commit, and it is often undesirable to couple the service to both the database and the message service. For example, if the database will supporting the language or the framework would not support the 2PC. So in order to handle that, we come up with a solution called transaction outbox pattern. So whenever an order has been received to the our order service, within the database transaction, one is our primary order table and another one is our outbox table. We are storing the events which are happened only, I mean which are saved into our database only. So once the order has been changed, I mean order has been placed, we need to save in the order table, and also we need to register a callback. So within the transaction we are using on commit. So whenever a message has been committed, which means a successful message has been inserted into our database, then only we will be calling our outbox table, I mean the function to save in outbox table, and the message relay, which is acting as a, how to say, the worker between our message broker and our outbox table. So the message relay will continuously poll our outbox table, which is acting as a webhook. So whenever something happened in outbox, it will be processed by the message relay worker, and it will be giving that message to our message broker. So it will be helpful in building something called pub models. So the main participants in this pattern are the sender, who sends the message, and the database and the outbox table within the same transaction, and the message relay sends the message stored in the outbox to the message broker. So the message broker will able to handle the message, and it will verify which service has to process this message. So in this system, I have implemented I mean many microservices, just a transactional outbox pattern. So how I solve this problem? Let me make a practical demonstration. So yeah, this is our architecture. The client sends a request to our API, which is a post request, and the Django API view will handle the request. And if the insert is successful, it will be writing to our database PostgreSQL. If it is not inserted, then it will not insert it to our another database called, I mean another table, outbox event table. So once it has been saved to our PostgreSQL, the relay worker process, what it has to done, it pulls the outbox table in the database and take the message from the outbox event table, and again makes our HTTP request, post request to our webhook receiver, which is our message broker. So it will be verifying whether it is a 200 error or 500 error. 200 status code OK, which is in green symbol, and 500 error means there is something an internal server error, such as network fails or anything. So this is our system architecture, and the transaction workflow maybe looks like this. The client and the API layer, how the request has been processing is all being explained here. So these methods select for update, and all the things will be explained in the code, because we need to apply row level logs to our database for handling concurrent requests. So yeah, this is an system architecture as I mentioned, and the transaction outbox pattern solves this problem called a dual rate problem. So yeah, the patterns I have used in Django, such as Django signals. So these will be executed when something happen in our system. Let's say an order has been created, our model has been affected. So then the signals will able to know, okay, this happened, I need to process something. And transaction dot on commit. As you know, in databases we use something called commit. So whenever is something is happened, we'll be committing that message into our database. So Django will comes with an inbuilt method called transaction.onCommit, which is present in the transaction package, I mean transaction module. It registers a callback to the execute to be executed. So whenever the message or the order is has successfully inserted into our database, it registers a callbacks, which means a function that need to be executed after the commit message. So executed only after the current database transaction successfully commits. So this helps us from creating an outbox event for a transaction that ultimately gets rolled back. So let's say if something happened in our system, the database just roll back its request. So we don't want to send that event to our outbox event table. So event is nothing but a process or work that has been happened. For example, an user click a button. This is an event. And user scroll to product space. This is also an event. So likewise, a event is nothing but something happened in our system. As I mentioned in the real-time example, we have a restaurant system. So whenever an order has been created, it will be successfully saved to our database, and we need to call our billing service. So in this system, we can assume that outbox table. Yeah, coming to the code. I have implemented this project in Django. So config is our project. Yeah, orders is nothing but our app. Look at this signals.py. I have created on commit message. So whenever a request, I mean the sender is nothing but our order. Whenever an order has been created, this method will be executed, handle order creation, and it will taking parameters such as the sender and the instance, nothing but the object and the keyword arguments. For a the request can contain something called metadata or something. So that's why I use keyword args. If already created, we'll be assigning that order ID, product ID, and quantity. So after successfully committing into our database, we are calling this create outbox event. This is our create outbox event. For every request, we are assigning an UAU ID, universal unique ID. If an idempotent key is already there, then we don't want to create that. So that's why we are get attribute means we are extracting the UUID. So why we are using UUID means when an user has been trying to place an order. So meanwhile, in between the request, the network drops. So the user tries to make another order again. So there will be duplication. We need to eradicate that too. So yeah, outbox is nothing but our another table within the database transaction, and we are creating these things. So Django internally create converts this into insert into object events. I mean insert into outbox events, and we are assigning all these things. Coming to the models, these are nothing but our SQL tables. Django internally converts these into SQL commands. Class order, which consists of product ID, quantity, and the status. And whenever a user has make a user, we will be defaultly creating created message, because we are assigning with the 201 status code. So defaultly we are creating, making it created, and we are checking the constraints because quantity cannot be negative. That's why we are applying this constraint on the database level. So yeah, quantity underscore GT means quantity should be greater than or equal to 0. The queue object is nothing but it will be helpful in Django queries. I mean Django to SQL queries. Queue object can be helpful for complex and join queries. Let's say if it is not possible to extract everything using normal filter method. So using queues, we can make complex queries easily in Django. And another outbox event table. It consists of all these aggregates: the aggregate ID, the event type, payload, and idempotent key. Look at here, we are assigning it to UUID field, universal unique identifier, and defaultly we are creating an UUID, and we should say it should be unique equal to true, and it cannot be editable. So that's why we are adding this type of constants. So yeah, this is our coming to the serializers will be helpful for converting our JSON objects, I mean JSON request to Python objects and Python objects to JSON. So these act as a gateway to our request, and these will be helpful for validation of the request. So let's say if user is not sending the quantity, it should say it should contain the status field also. So without that, the serializer would return 500, not 500, status code error. If user sends something, quantity is negative number, it should say 500 internal server error. These are the serializers and signals. And views, which is nothing but our business logic will be executed. So just here we are just accepting the HTTP request and checking whether the event is already existed or not. So we have decoupled the system, not written everything. The business logic is not written everything in the views.py. And the next thing, I forgot to mention the application is completely containerized, which means you can run it anywhere with Docker desktop installed in your system. So the services are mainly the database. I will be using Postgres 15 Alpine, and the app which is inside the Docker container. It will be built using this source code. So that's why we are returning dot. It will say use the image of this root directory, the Docker file, and build according to that image. And inside the app container, we are just creating a volumes. So the data would be stayed on the volumes whenever Docker containers are created and deleted, and just adding some health checks and the webhook receiver. So as mentioned, the webhook receiver will pulse the, I mean, the message relay worker will pulse our outbox event table and process that events to our message broker. So running on 5000. So it's just an simple microservice built using Flask. Let me show you that also. Yeah, our mock webhook. So it will be running on 5000 port and the endpoint is slash webhook slash receive. So whenever there are some events in the outbox table, it will extract them and returns message with the status code 200 success. So that's it. Define the endpoint at orders. Okay, let's make the practical demonstration of the project. This command will build the containers. So as I have already run this system multiple times, it will be done faster. So when you are running on your system, it may took some time, say 5 to 10 minutes, because it need to install everything that is written in the requirements.txt. So the Django REST framework and the database URL, we need to send the database URL from .env file to our settings, because in productions the database URLs are mainly cloud based ones, so we don't want to expose our databases URLs. So it's a good practice to use environment variables for securing credentials. And the psychopc to binary is nothing but our SQL adapter, which needs to talk to our database. And the requests is nothing but for making requests. Actually, it is a synchronous one. Coverage is I have used for test coverage. Testing purpose, I have used this coverage module. So yeah, everything was created. And I forgot to mention about the base command, because I have created a custom management command called process outbox. So this will extract the events and process them from the outbox table. So yeah, you can look at this. I'm using Django management dot base. We are importing base command, and whenever a developer needs to know what's this command, he can simply type python manage.py, the command name hyphen hyphen help. This message will be printed. It will process the pending outbox events and relay them to the webhook. So instead the handle method, we are just writing or getting the credentials such as webhook URL and maximum retrace and base delay. So yeah, while true means, so if there are events on our system, I mean the outbox table, we are trying that to process batch. This process batch will be executed. This method will be executed. So we are extracting the current time, and this logic is wrapped in a transaction.atomic phase. So as you know, there are four acid properties: atomicity, consistency, isolation, and durability. So what do you mean by atomicity? Either all has to fail or all has to be succeeded. So we have defined with the transaction.atomic a built-in method provided by the Django, and we are querying, I mean we are getting the events what are there in our outbox table, outbox event table dot filter, which are status to be pending. And again we are filtering next retry. So whenever a network request drops, so the event is not succeeded, so that needs to be handled. And next retry at less than or equal to now. So I have used select for update. This applies a row level lock for our outbox event table, which is helpful for handling concurrency. So let's say another events are being again generating. So we don't want to be handle concurrent requests at a time because the worker may be failed when handling the multiple requests at a time. So this will extract the 50 rows at a time, and skip log could equal to true means we are applying a row level lock. And for event in events, we are just processing the event id. If everything was done and the response status code is 200, we are just setting the event status as processed. And not only setting the status, we are saving in the database. So we are setting event.save, and we are just writing in the terminal that the event is sent successfully. So whenever something is not happened correctly, we need to handle that failure also. So that's why I have defined something called handle failure method, which takes off maximum retries. I mean, for every request, we are assigning a maximum retries because everything can't be succeeded at a time. Maybe there are some failures. So whenever there is an request exceptions or network error has been happened, so we will be printing as a network error for that event, and we are just simply handling that failure also. Let's see what this handle failure. It calculates the exponential backoff and updates the event. So just we are importing date time, and we are just incrementing the retry count to 1. So if again retrying is more the time than maximum retries, we are setting that status to fail because we don't want our system to get into an infinite loop. So that's why we are adding this constraint, and we are setting that message as failed. So we are just printing that the maximum retries exceeded and marked to fail. So what there is some possible to process that message where the maximum retries is less than event dot retry count. So we are using called exponential backup formula. So for every 2 seconds it's incremented. For let's say event dot retry count is 1, it will be incremented to 4, 6, 8 seconds. So in that way we are incrementing, and just we are incrementing with time zone dot now. So on the user side server time plus the date time of time, that the difference between the delay seconds and this time zone not now, so the time will be increased. So once that is processed, even there is some failure, then we are updating the fields of the event. So this is how I created a custom management command. So yeah, in everything is running. So yeah, as I have already mentioned, this is the custom management command I have created. This is not a built-in command. So you may say python manage.py start app, your app name. So those types of commands are built-in commands. This is our management command. See what it's printing. Yeah, the started outbox relay worker. So this is the message we are printing in the terminal. Let's send an request to our system. So that's why I have created everything in the notepad. So there are some 9 messages before, so that the id will be 10, and the product id will be product 1, and the quantity is 5. The status is created. Okay, let's send the same message again. This time it will be not create. So another message not been appended. The same request, because we are using something called idempotent key, the id will be same, the 10, not the 11. So let's check some other things. Let's check whether the -1, we are sending the quantity as -1. So this will be creating an integer error at database level. So I'm just changing an identity key. So the database thinks this is a new request, and seeing that quantity as -1, you can check the Docker logs. So you can see that validation error because the quantity cannot be a negative value. And yeah. Looking that there is something error called UUID error. So let's fix that too. So the error comes from the UUID, not the quantity database error. So still the error is because of this. Okay, let's change the UUID. You can simply generate a new one because we are using UUID 4. So that's why we need to generate that type only because we are explicitly mentioned in our models.py to use the UUID version 4. Let's try to send a request which is quantity is -1, and we are just changing this UUID FG. It's still saying it is not a valid UID, but it is not saying that this is not a negative integer. Let's fix that too. Okay, just we are removing the containers and building the containers again. Maybe due to some cache. Yeah, you can see the empty reply from server. Okay, it's not built again. Yeah, this time it got the something called failing row contains the quantity must be positive. We are setting the quantity as negative number as -5. So that's why it replies with the negative 500 internal server error. And we have already seen that when the idempotent key is same, it thinks as the request is coming from the same sender, so it avoids the duplication. Okay, let's run the tests. I have created nearly 7 tests, automated unit tests for checking the robustness of our application. Compose execute and due to the typo. Yeah. So these are the tests I have created. So the first test, create order success, creates outbox event, because we need to store that both the events into our database as well as the outbox event table. So the problem we are facing, as I mentioned in the earlier, writing both the things simultaneously it's not possible. Sometimes it may fail. So that's why you're implementing the transactional outbox pattern, and the test identity prevents duplicates. So when you are sending the same request, so the, let's say the headers will be this, and first request we are sending and another second request we are sending, and we are storing both the responses in res1 and res2. So the first thing, the first request will return status code 201 create. So the asset method will check both the values are correct or not. So the status code and status code 201 created should be equal. And here the status code and the 200 okay. There is a difference between 200 and 201. 200 is just saying okay, it is valid. 201 say it has been created, and we are just checking the count whether sending multiple requests or idempotent request can leads to increase of the database count or not. So both returns one. So yeah, next thing, create test order invalid payload. So as mentioned, we are just sending the product ID as test invalid, and we are missing the quantity. So that's why the event 3 has been failed. And transaction rollback prevents outbox creation. So yeah, whenever a database crash has been happened, we don't want to send our event to our database table. So like this, I have created some 7 comments and one thing for our custom management command. So I hope everything is clear for you. You can access this project at the GitHub of my Sachinaga Praveen Kumar / transaction outbox pattern. These are some, and I forgot to something called reports, because our spec, I mean, the specification need to be coverage report of about 70% of the testing suite. So this will create an report about our testing strategy, and it can be also able to view in an HTML page. By running this command, you can see the HTML documentation. Okay, system list should be the table plot, the order say outbox event. In a production environment, a separate cron job. Yeah, a cron job means based on the time it will be executed, and we are just deleting the records older than the 30 days. This should be happen because in production there might be billions of rows will be appended to our outbox event table. And worker process management. So this running is for demonstration only. In production, this relay worker should be replaced by something called system MD or supervisor and deployed as an independent Kubernetes pod. So you can refer to the setup and installation. Yeah, the test coverage says that it is 87 percentage. So it is covered everything. So that's it guys. How I implemented the transactional outbox pattern in Django. You can comment down if you have any doubts regarding to code or architecture. Thank you.